And output grapher is essentially a graph of data about the model, and information such as the forces or positions of specific joints in the model, um, accelerations, velocities, but more what I was specifically coming in here to do, and we'll go through the output grapher throughout the demonstration, but what I wanted to do is actually look at tracers, or add traces. So a trace is actually a point within the model that is important to you. So I'm actually going to right click on add, or on the trace option here, and select add trace. And what you'll see is you get a dialog box where you can add the tracer. The first column is the display, so what's going to be displayed in the scene itself, and right now trajectory is selected. Um, the next column is output value, or output information, so what information is going to be collected, and I'm going to go ahead and check all those. I'm actually going to set my trace to pink because it stands out on the gray background, and I'm actually going to zoom in into the model and pick a specific point, and that point is right here at the end of the arm. So if I apply that and cancel out of this dialog box, now in the output grapher you can see that I have a new trace, and I'm going to actually rename this while I'm here because we're going to add more later in the demonstration and I don't want to get them confused. So I'll name that one arm. And here you can actually see I've got position graphs for the simulation. So I am going to go ahead and turn on the Z dimension, which is the vertical dimension in the model. And the reason I wanted to do that is point out this graph. I'm using the middle mouse button to actually zoom and pan in the graph, but I wanted to zoom in on this starting point. This starting point actually, 0 is where the ground plane is located. So if you look at this trace, what I'm seeing here is that just before or just after we start the simulation, the arm drops into a negative position. So if we play let me get the simulation player out from behind that dialog box, and let's go ahead and play this, and you can see the graph and the simulation running at the same time. So right when we start, you'll see the arm drop along with the graph. So this is providing you information in a graphical and visual format in the scene as to what's happening in the simulation. I wanted to call out this specific point because we're going to actually, with the first joint, fix this. And it will change the graph and the tracer. So I'm going to go ahead and close the graph for now. And let's jump back to construction mode, and we can go ahead and make our first joint to work on making the arm drag along the floor. So in construction mode, the insert joint option becomes available. And when I click on that, I'm going to get my insert joint dialog. And in this dialog, you get a drop down with a list of all the different constraints or joints you can actually create, with an animated preview as to what that's actually going to do or create in the model. So here you can see a gear, and a spur gear and a running along in the animation. You could also see, for example, a cam and a follower, but you get an idea visually of what is going to be accomplished by each joint. In this case, we actually want to create a 3D contact joint, and that is going to tell these two components that they interact with each other. So I'm going to go ahead and zoom in on this arm, and we can start adding joints. So in this case, I want the ground plane, or the ground part, to interact with this arm. Now, I picked this face just because it's close to this, and it's a quirk of mine. You can actually pick anywhere on the part, but I'm going to go ahead and apply that and cancel out of this dialog box, and now you actually see the force joints have been added back into the browser, and our first constraint is there, or first joint is there. So let me zoom to the side now, and let's rerun that. Let's turn the output grapher back on so we can actually see it running next to it. go. So now when I hit play, what we'll see is the tracer start in the scene, and as you can see, instead of dropping through the floor, it's actually being dragged straight. And in the grapher, you can actually see the same result. Rather than dropping negative, it gets dragged along the floor before it takes off. So we've actually fixed the problem, the first problem that we had, and we can move on to looking at other components that need work. So let's go ahead and I'll stop this simulation and jump back, and I'll center this. So the next item, if I drag through the simulation, so the next item that I notice is the ball. It's not being picked up by the arm. So we haven't told the system, the ball was not constrained to the arm in any way in the assembly mode. So we actually need to tell the system about the interactions of some of the components. And just like we did with the arm and the ground, we're going to add 3D contact joints. And I'm going to go ahead and jump into construction mode. And I'm going to actually add a few here since you've already seen me add one. They're all done in the same manner. I'm going to go ahead and insert a 3D contact. And the contact points are between the ball and the ground. We know those two need to touch. So I'm going to apply that. I also want the ball to interact with this arm. And I'm going to apply that. And last but not least, I'm actually going to have the arm interact with this rubber stopper here. So now if I cancel out of that, you can see, oh, we've got a bunch of new joints in the browser. And I'm going to turn to the front view. And go ahead and play that simulation now. Now, what you can see is the simulation is actually playing, and you can see the beginning of the tracer there. But what's happening is it's getting hung up on the ball. If you zoom in here, you can actually see that it is wobbling. Let me go ahead and stop it, and I'll start it one more time so you can see it up close. Let me rotate a little bit. There you go. So if we hit play now, you can see that it's getting hung up on the ball. And there's a reason for that. It's actually working the way it's supposed to. If we go into construction mode and we look at the grounded components, you can actually see that the projectile is listed as a grounded component. So what's happening is it's doing what it's supposed to. It's keeping the projectile grounded, and the arm is actually interacting with that, and it's getting hung up on it. And the reason it's grounded is I mentioned in the beginning of the demonstration that anything that doesn't have assembly constraints in the assembly mode is going to be placed in the grounded group. And this can be fixed with a spatial joint. So I'm going to go ahead and go back into the insert joint dialog box and look for a spatial joint. And what a spatial joint is a joint that tells the system that an item has full degrees of freedom. So in this case, I'm going to select the projectile, and normally, or in some cases, you'll need to use align the axes to other components in the assembly so that the model knows how to move within the system. But in this case, since it's a ball, we actually don't need to do that. I'm going to go ahead and click the second component, being the arm, and I'm going to apply that.